The third species is No.08E japonica. The main character of this time. As introduced at the beginning, No.08E japonica, this species spends a long period of time from June to April of the following year. ICHIKAWA and others have classified their development into 5 stages in a 1955 paper. Later, ISHII was in a 1988 treatise, which was reorganized into 8 stages. For the D1 and D2 stages, Honda has taken pictures at No.08E Puzeroi, so we will show you the pictures. In 1971, Hidaka et al. Managed the pupae of No.08E japonica in a state of no light under various temperature conditions. And they showed that adults did not form in the pupae when the temperature was high, but adults formed when the temperature was lowered. Subsequently, ISHII conducted a wide range of experiments on the growth of No.08E japonica pupae by controlling the temperature and daytime length. And inside the pupae of No.08E japonica produced in Kyoto City, which were bred and managed outdoors on the premises of Kyoto University. He also investigated the progress of adult pupal formation in Kyoto. As a result, they showed that adult formation begins in November. In addition, he described when pupae are bred from larvae at a temperature of 20 degrees. Adult formation begins when the daytime length is 14 hours or less after becoming pupae. But the daytime length is 12 hours or less during the larval stage. After becoming a pupa, the individual begins to differentiate into adults even if the daytime length is 15 hours. Furthermore, the larvae, that spent 16 hours in the daytime between the first and third instar larvae started to form adults when the daytime length was 14 hours after becoming pupae. So from the first instar larvae, the length of the bright time between the third instar larvae affects the subsequent adult formation. In addition, the emergence of No.08E japonica requires the pupae to be exposed to low temperatures. But the period of 20 degrees before putting them in the low temperature should not be too short or too long, and the temperature should be low. It was shown that if the period of placement is too short, the emergence will be delayed and the wings will not grow. As described above, many factors are complicatedly related to the progress of adult formation in the pupa of No.08E japonica, and its management is very important. Therefore, this time, we planned along with the report that followed, the adult formation in the field during the No.08E japonica pupal stage by soft X-rays introduced in 1997 based on the achievements that many people have accumulated, so far. Pupae are spent in the shade of the deciduous forest left on the premises of Tokai University until the end of November, after which about 4 degrees except when imaging. We managed to store it in a dark place around 4 degrees and return it to room temperature from mid-March. Also, while managing the pupae outdoors, we recorded the temperature of the place where the pupae are installed and checked the response to changes inside the pupae. Initially, the coil used to image the pupa of bianor was also used to image the pupa of No.08E japonica. However, the volume of the No.08E japonica pupa was only about 40% of that of the bianor pupa, and the signal strength required for imaging was not obtained with one pupa. So it was necessary to image 2 pupae at the same time. Fortunately, however, it became possible to use a product with a coil diameter of 10 mm, and it was found that this would give a much clearer image. So we decided to use this coil for imaging the No.08E japonica pupa. The imaging is based on 1988 paper in ISHII. And first, the images are taken every day until the 15th day after pupation, and after that, there seems to be no change until the end of August. So we took an image every 10 days. And since it seems that the change will start in September, we took pictures almost every day until the end of November when this change ends, and after putting it in the refrigerator, we took pictures once a week. Then, after returning to room temperature in March of the following year, we basically took pictures every day until they emerged. Let me show you the result. In the picture of the Japanese No.08E and the following Parnassus glacialis, the number of days elapsed since pupation is displayed at the bottom left of each figure. First is the result of the male butterfly. For a few days after pupation, the cavities under the mouth and legs grow larger, similar to the bianor diapause pupae, but this movement subsides in about 2 weeks and remains unchanged for a while. The next change will be seen about 140 days after pupation, around the end of October, when gaps can be seen between the mouth and antennae. However, this movement also settled around mid-December, and after that, the period when no change can be seen continues. Then, when the pupae are returned to room temperature and a few days before emergence, the appearance of the adults in the pupae can be clearly seen. However, such a change could not be confirmed in Papilio bianor, male butterfly. In Papilio bianor, testes could be confirmed before emergence, but in Loeterphia japonica, male butterfly testes could not be confirmed even just before emergence, and it is considered that this is a characteristic change just before the emergence of Loeterphia japonica. Next is the result of the female butterfly. After all, it showed almost the same changes as male butterflies. Comparing the above results of Loeterphia japonica with the results of Papilio bianor diapause pupae, Papilio bianor diapause pupae did not show any significant changes during the period under low temperature control, while Loeterphia japonica pupa showed some changes in this circumstances. This correspond to the results which confirmed to the paper showed the article published by ISHII in 1988. The last species is Parnassus glacialis, in which adults appear to replace the Loeterphia japonica. Parnassus glacialis overwinters in the shell of an egg as a larva, and in early spring, when the Loeterphia japonica emerges, it comes out of the egg and eats the Corydalus incisa, etc. It will emerge in early May. Although no detailed studies have been conducted on the growth of Parnassus glacialis pupa, the pupa follows a similar course to the non-diaposing pupa of the Papilio bianor. So it was imaged every day after becoming a prepupa. As for the coil, we used a product with a diameter of 10 mm, similar to the Loeterphia japonica. First is the result of the male butterfly. Overall, it showed similar changes to the non-diaposing Papilio bianor pupa, but if you look at the picture just before emergence, you can see the structure of the adult form like Loeterphia japonica. Next is the result of female butterflies. It was found that this also has the same changes as the male butterfly except for the reproductive organs.